Okay, so we're back here. I've got a short period of time before I've got to go get pizza from the door, so at any minute I can cut this and I'll be back, so there'll be just a cut in the video. So heads up on that. But we're gonna go over what happened between last video and this one. So in last video we were working on the effect layer system. I did tweak it more. I ended up having to add a rotation-based system to the effects system. This is implemented via the MBT tag that is being brought in from the server. So the server will send an MBT tag. It'll contain the yaw, the pitch. It also contains the aim. So if we want to use a secondary velocity or something, we can put that in there as well. We will be synchronizing even more and more data about the shooter entity and about other things through this packet system. That way, anytime the effects go to fire, they have the most data available to them to work. So with this, we fixed the lasers. So I'll go ahead and run debug, and I'll show you the twin lasers working. Previously, they were working. I believe when I cut off the video, we had a laser above and below. I did fix them so that they were both in the correct position. There was an issue with the pause array reader. I switched from the pause array reader to the object array reader. So that it is now working properly. I still have to go debug the array one. I think it is fixed, but I didn't want to toy with it to see if it was working or not. Additionally to this, of course, I did adjust everything, so I got the sizes correctly. I do need to adjust the barrel length a little bit more, and there's a few other things that need to go into adjusting and making things work properly. I did turn the reload time and firing delay off on the laser, so the laser literally just continuously fires at the target. This means I will have to drop the damage down on the laser beam to balance it with everything else, as the laser turret was meant to be a low damage weapon that just was a continuous fire weapon. So high rate of fire, low damage, continuous damage on target was meant to be its effectiveness. It also caught the target on fire, so the fire did additional damage. This also made it really ineffective against players, though, because there's fire protection for armor, and there's a few other types of damage types that just kind of completely nulled out the laser. And that's going to be an existing thing. There is going to be a difference though. The laser will do impact damage. So the very force of the laser hitting the player will do damage. So there'll be a percentile impact. There will then be a thermal, and then whatever laser type is used, there'll be a system for that. Right now I think we are using infrared lasers, so it's just going to be heat-based damage. There will be like ultraviolet, which would be heat plus a couple other things, because ultraviolet is not the same as just straight out infrared. We'll figure it out as we go. I believe visible light we are literally just going to use as damn, I always get something caught in my throat when I'm recording. But visible light we may just do impact damage only, but I gotta do some research on that. Okay, as you can see, both the lasers are rendering. You could probably notice with the barrel length is that the lasers are still rendering slightly above. The center of mass on this is also not set up correctly, so there's a slight hindrance on this where tweaking still has to be done. We're not actually going to focus a lot on that in this video. That's stuff that just I have to toy with and toy with and toy with more, and I might wait until I got my in-game editor to just readjust all that stuff. But as you can see, it's working. We are getting a continuous beam. It is literally instant killing things because it's doing almost 100 damage a tick, or 100 damage a second right now. That's where I got to drop the damage down to like a value of 1, and then add a fire effect to it, so it'll catch entities on fire on impact, and a lot of other things that has to be done to this. I might also toy with how it does damage to each thing. Like for example, undead monsters will take more damage from laser guns versus normal mobs. Creepers will have a chance to explode when you go to do it, set them off. There'll be a few other tweaks to make this more immersive, but that'll come here later. For this video, let's think of what we're going to do here. Not a lot to really work on. I know exactly what we're going to do. We're going to set up this to consume energy. So we're going to set up the turret itself to take and consume energy. Now the gun instance on its reload cycle should already consume ammo or consume energy. We need to code in a few things here. So when we go to, say we have ammo, so there's a has ammo check in here somewhere where we were toying with previously. we need to implement some kind of behavioral logic to drain ammo. Now, I'm trying to think of how the best way to do this. We could create a fake magazine called an energy mag, and that would be a decent way to do it. Um, hmm. We could do a do fire check, so we can go, okay, if we have enough energy, we could just fire the weapon. That actually might be the best way to do it because see, we have a get chambered here, and next chambered round, I believe, does not fire if we don't have ammo to start with. Since it's a laser weapon, we don't have ammo, so we can't do that. So this entire check might as well not exist. So we just do get chambered round. If we go to do fire, we don't have a get chambered round, then that would be a great way to do this. So we're going to go here. So there's a get chambered round. Okay. We're going to make a method below here, and we're going to go has energy. Boolean has energy to fire. Actually, we're going to go put this not in the get chambered round. We're going to go put this up on the top because there are munitions that will require energy to fire. A railgun, for example. You would have a bullet, and then you would have energy. There would be a few other things that would have to go into play. I still need to figure out how we're going to do black powder weapons, because black powder weapons you have to load black powder, then you have to load a bullet, and plus there's usually like a little piece of fabric in there to make the bullet work more effectively. That's going to have to be handled, and I don't know how to handle that precisely at the moment. For this, we return false by default. Then we're going to go, okay, we need to get energy from something. So first check we want to run is we want to get our stack. It's not two stack. Is there a way to access the stack directly? We're going to check this real quick. It's probably a private method. Oh no, it's just called item. Here we go. We just do this. So we want to go item doesn't equal null, and item dot get item instance of I energy item. So we're really just going to check the vanilla, or I mean my volts engine base class, which is I guess vanilla. And this provides us basic recharge and discharge, which will do the trick because we'll just call discharge and we'll call false on here. If you're familiar with energy, this literally works the same as the RF handler. Yeah, there's no difference. So we want to return item.getItem.discharge, and then we want to pass an item, the amount of energy we need, which is going to be get chambered round get energy cost, and we're going to do false. So this will be our baseline thing. So we want to just go if this is greater than or greater than equal to get chambered round get energy cost. So we want to make sure that if we go to call discharge that we get the exact amount or greater back, because if it's passing in greater, that's its own prerogative that it's broken. The next thing we want to do is we want to go with our shooters and energy class. This has several benefits. For starters, we can apply I energy to the actual shooter interface, and then that'll give zombies, for example, power. So if you want to put a power pack on the back of a zombie, but we don't want to edit the zombie class directly to put a power pack on them, we can simulate it by making the shooter class act like it has a power pack. This also means that the sentry can directly implement the I energy calls. The player doesn't need to do it either. We can actually access the entire player's inventory looking for batteries to drain from, utilizing the same exact system. So for this, we want to go with weapon user instance of I energy buffer provider. The reason we're doing provider is it gets an I energy buffer. So I energy buffer equals weapon user dot get energy buffer, and we want to pass in forge direction dot unknown because this is an internal call. I use unknown as internal calls, or as it's intended to be used as an unknown. We don't know what direction we're in. We want to check to see if the buffer is null because we may not have a buffer for whatever reason. And then you want to turn basically the same thing as we did above. So we want to go remove energy from storage, and then we want to get the energy cost. We want to pass in false because we're not actually doing anything, and then we want to go do this. and that gets us our energy to fire code. Then we just make a similar method down here, which we're just going to copy this, and we're going to call it drain energy. So this will be consume energy, and what we're going to do here is we're just going to pass in, actually no, we're going to do a Boolean for this too. Boolean do action. This way we can recycle this. So we don't have to, any chance you get to make your code double reusable, it's usually a good idea to just go ahead and do that. And then we'll pass the int code back, and then theoretically we could actually put this code up here, which, you know, it's not a horrible idea. So we're going to do it this way. So we're going to go consume energy false is greater equal to get chambered round dot get energy cost. You know what? We want to make sure we get chambered round is not null, so we don't break the game. Oh, energy item hasn't been updated in a while. We're using an int-based system for energy right now. I decided to do it this way because I don't really care about precision. If you have 1 watt of energy, you have 1 watt of energy. If something wants to store microwatts, it can do it on its own. And then it just has to decide if it wants to round up or round down. I may come back through here and add a system so we could do microwatts and stuff. So you would have some kind of scalar measurement you'd pass in or something. We figure it out later. Energy is just now being implemented in most of my mods, and it's not that big of a deal for us to keep track of precision. Most mods don't care. RF doesn't care. It makes the math so much smoother if I don't have to translate between ints and doubles and back, because there's a lot of rounding problems if you do that. This code's good, so we get it back exactly. So we have consume, we have has energy, and then what we want to do is make another method here. So just call it consume energy. This will just be a wrapper method real quick. So this will be return. Yeah, we just want to return this real quick. Greater than 0. This will be a true method. So we can call consume energy, we can call has energy, and we can make our lives so much easier. We could, in theory, place this code right here into the weapon user class, and then we can just let the weapon user decide how it wants to do things. I'm not going to do that right now. I'm just going to go and pass stuff back and forth. Let's see. So when we go to fire the weapon, which is right here, apparently somebody got the pizza already, so I don't have to pause this video. That's 13 minutes. Wow. The fuck pizza place is that? We're gonna put it in the do fire. And so here's our ammo checks. Our first line is, do we have a round to fire, pretty much. Then our second, thank you for my pizza. Okay, put that on my bed and hopefully my dog doesn't attack my pizza. Let's not put this here. So first line's our ammo check. This is then our chambered round if we don't have a round check. Right down here, then we have something. Then we're going to go has energy to fire. And then when we go down to consume shot is when we actually consume the shot. So here's our previous code, which I wrote to handle energy. We want to get rid of, we just want to get rid of all of that code. And we're just going to do this, consume energy. Just put a line down there. So that'll function. Should give us what we want to use. This does mean that we have to go over to our actual sentry tiles and we have to apply energy code to them. I'm in the core, I don't know why I'm in there. Let's see, armory, data, Okay, so there's the sentry data. That's not what I want. I want the sentry code, tile sentry. And then I just need to apply I energy buffer provider. By the way, all the energy code we have in Volt's engine is designed to be handled via this way. It's a lot smoother that way. Apparently we already have energy buffer code built in here somewhere. And it's probably in here. Yeah, right there it is. There's definitely an override in here. Get energy buffer size. So we need to copy this method. And then there is some more code we need to add to this, like we need to do consumption of energy. I'm probably going to handle that in the tile itself. Actually, let's not put this here. Let's put this down lower. Yeah, right there's a good spot. Oh, wow, I didn't realize I had a... No, the code's all already implemented? The interface wasn't implemented, but the code's implemented. That's odd. Oh well. Means I don't have to do anything. Get sentry doesn't equal null, get sentry data doesn't equal null. Sentry data can never be null technically, but I'm not going to change it. Yeah, that looks good. So we're going to go see if it'll consume power. If we log in and it doesn't fire, then we know by default it's doing what it's supposed to do. I gotta find a spot to stick his pizza that is definitely not on top of my bed, or my dog will pile onto that bed and try to eat that pizza. So let's try to toss some stuff off my desk. Kind of wish I had a bigger desk. I'm right now using a kitchen table that I believe has been in my family since even before I existed. It's an old pine one. Probably used to cost like $100. Now it's not even worth 10. It's a nice table though. Just needs some sanded down, maybe repainted. New screws. Too many notebooks on my desk. These I can toss on the bed. I don't have to worry too much about the dog attacking notebooks. Pizza though. That dog is like, could eat anything she wants to eat and still be hungry. And if I twist it this way, I can access the pizza. I know you guys can't see my my desk. Eventually I'm gonna get a webcam. I don't know when. Eventually. I gotta get the money for one. And I gotta go do some research where good webcams and stuff, and I wanna get one that would point at my desk, and I wanna get one that points towards me. Desk primarily. Not so sure if I'm gonna do the one pointing towards the face a lot though. Maybe during live streams I'll do that. Recordings not so much, still a little weirded out by the whole webcam thing. Been paranoid about webcams forever. I'm one of those people you will find that I have a really nice laptop that has a really nice webcam built into it, and there's a piece of duct tape right over top of the webcam. Not quite duct tape. I think I actually use last time I used to have a laptop. I don't use laptops anymore. He's still firing, which means one of the checks is not working, or we forgot to initialize some data when we made the Sentry Gun. So Sentry. Okay, so this is our energy cost theoretically to fire. You know what? I don't think there's an energy cost on weapons. I think there is literally an energy cost on munition. Let me check. So if we get the gun data, which is at the very top of this class, and if there's an energy method in here, we can use it. There's not. Okay, so I do need to check the gun data though directly in case that there is something in there, and we're just not using it. So be under ranged gun data. There is no energy in here, so that energy line is useless. This actually means I need to make a new ammo type, which I needed to do anyways, so we're gonna go and copy the ammo type for laser guns. Okay, I'm in tests. I'm not thinking clearly today. Okay, so this is what I want. I'm going to copy this. We basically just want to make it a subtype of laser ammo. So this is going to be Well, actually, we need to make sure we ID this as our laser type. And we're gonna just keep it, we're just gonna call it laser, and we're gonna say it's the same laser type. We're gonna set its damage to 1 for impact. We're gonna then make a second damage type on here. So this will be -1. We can leave that there. And then we're gonna make a fire damage type. I don't know if fire is actually supported damage type, but we're gonna find out pretty soon. That looks good. There's a couple things I probably need to do with here. Like I need to probably make an effect damage type that's designed specifically to apply effects to entities and not to actually damage entity. That'll be used for the potion effects, which the code does support potion effects already. There's just no prefab for it. And then we need to put our energy cost in here. So I need to go find ammo data real quick and see what it calls the variable. So ammo data. Energy cost, and it's probably down here. Yeah, energy cost, and it's an integer. Okay, so how much we want to cost this? Let's say 200 joules. And this is self-balancing. If anybody wants to come change this variable, open the jar file, change it. There'll be overrides implemented later, so through external folders you can change all this you want. Let's see. Yeah, looks good. Means I just got to restart everything. And then I gotta attach a battery box. As soon as we get this all done, I'm going to cut this video here, and I'll be back with probably another video. Because I got pizza, and I want to eat it while it's warm. Or I got a dog who's trying to, well, eating a piece of crust, which I don't know where she got from. And if as soon as she's done with that, she's going to be sitting and staring at me going, pizza. Although, for all this out, you really shouldn't feed dogs pizza. It's bad for them. But, yeah, the rest of my family doesn't quite understand that. Let's see, anything going on in chat? Nope. This is going pretty well, though. Eventually I'll get a prefab out here for energy, too, so we'll just be able to go through the JSON data, apply energy constructs to things. Be able to do various other things. The plan is to get the JSON system to basically define the whole entire structure of a block, from start to finish. Although the way we get the Sentry Guns design, I don't have to worry about it too much. Taz, no. As I told you, dog's gonna start begging for food. Right on cue. Hey, come on. You know you're not allowed to have any of this. Go lay down. Okay, we're still firing. So we messed something up. So energy cost should be working. So we just need to follow through real quick and see what's going on. Okay, we're in the wrong class file. Okay. Okay, that's working. So maybe the weapon data is not applying correctly. Oh, you know what? I messed up. So go back down here. I didn't change our laser ammo. So we made the laser ammo, and we didn't specify the laser ammo. It also didn't identify the Sentry Gun as an energy provider, so we got to fix that. So we need to go to the content, sentry gun, and then sentry. And yeah, we're not an energy provider. Energy buffer provider. And all we have to do is wrapper this to our host. So put this down here. And then we just want to go if host is instance of energy buffer provider, host get energy or get energy buffer side, if not null. And that'll fix that. And we just hit launch again. I didn't mute my mic there for a second while I took a bite of pizza. Really good pizza. I mean, it's Papa John's. It's not the best pizza you can get on the planet, but it is still pretty good. When it comes to quality of pizzas, the pizzas are usually better than this. There's a place around here called Jets, which makes really nice pizza and submarine sandwiches. After that, it's Christie's Pizza, which is actually above the chain. They make amazing pizza. It's another local pizza place. You got Minutemen's. They make amazing. It's another local pizza place, of course. Then you got Italian or Mexican Italianos, which is a diner down in the south of Ohio that I don't know if they still make pizza, but when I went there, they made the best pizza I've ever tasted in my life. Nothing has compared to that pizza. It was thin crust pizza that was not made with conventional pizza sauce. It was more garlic based. Authentic, true like mozzarella. Like absolutely amazing pepperonis. Like those pepperonis had to be handmade. They were that good. But I think that place that most of their food was handmade. They're in a new management now, and I don't think their food is as good. Anyways, go down here, click. Okay, go in here. Let's hit a play marker here, so we can just hit play real quick. Okay, it does identify us as an energy buffer, gets the buffer, did not get the buffer, so something in our chain is not returning a buffer. So something's wrong. It means the host isn't set somewhere. So we're gonna hit play. This means that it will probably not fire. I need to change that debug, so that needs to be an energy debugger. Okay, so we know the sentry is a thing, so we know it's an energy buffer. Then its next direct host. So its next direct host is this guy. This guy is an energy buffer, and this guy goes to its host and asks for an energy buffer. So that means then it's our tile that isn't returning an energy buffer properly. So when we go down to here, we forgot to set the energy buffer on the sentry gun. So the sentry gun literally just doesn't have an energy buffer. Yeah, so that's what we need to do. So the sentry gun itself needs to set an energy buffer. I need to go figure out what that variable is called. So this is data sentry gun. Got tons of data in here. This is just going to get worse, by the way, as we go. More and more stuff in here. So there's an energy cost per tick, which we'll go ahead and set that one up as while we're at it as well. So this is up here in the sentry class, and we'll put it underneath laser. So we're going to say it costs 100 joules a tick to run this thing while it's on. And then we're going to say the energy buffer size is a couple thousand. So that'll give it 10 ticks of runtime for the buffer, and that'll let it shoot 5 times before the buffer empties. That's good. And of course, this will be upgradable. This will be upgradable, so you'll be able to decrease energy cost. You'll be able to increase the amount of damage your weapon does at the cost of more energy, and et cetera, et cetera. But those upgrades are coming later. That's something I'm not going to do even at all this month. So we're going to hit debug, and we're going to run it. I'm amazed my dog is being patient. The sad thing is she's slightly trained, so she shouldn't be the begging for food type. But she got the ideal from the other dog I had that you could beg for food. Which unfortunately the other dog got diabetes, so begging for food was something she did for hours. If you had anything she thought was remotely food, she would beg. And she didn't know how to stop because, unfortunately, because how diabetes works in animals, and it works the same way in human beings, you have this constant problem where you feel like you need food. No matter like how much, because it has to do with sugar imbalance. Although we right before like the dog died, we did get that mostly under control via insulin and diabetic dog food, so it wasn't as bad, but that really did suck. But that is a story for another time. Taz, no. Here, I'll pet you. That work? I'll give you a pepperoni later. Bribing the dog. The paracord, what I've read, by the way, when it comes to dogs' diets, they're allowed to have high-fat food and stuff, mostly protein. Starches are bad for them. Some vegetables are okay. Most fruits are bad for them. It does depend on the dog breed, though. Okay. Ah, you're still firing. Why are you still firing? How do you think you have energy? Okay, so it's got to be this line somewhere down here. So we have a buffer. We get a buffer. We come back to here. It thinks it has energy to fire. How do you think that? Okay, so something failed here, and we just need to go look at the data. Okay, so we have our override round. Our override round is what we actually use, although somehow we got a chambered round too. I don't know how that got set. Probably save data. It doesn't matter if it's set or not. The override round is what actually gets used. Its energy cost us 200. Okay, so it's set. Okay. So the has fire code is what's returning. And we go chambered round and we get consume energy, and we go get chambered round is greater than get energy cost. So this has to return higher. And remove from storage. So it has to be this line. So we want to dive into this line until we figure out where it's bugged. Okay. So it just went straight to our buffer for some reason. Should have went and found our buffer. Oh, I guess it finds our buffer above. So max storage. Okay. Why is our energy storage negative? Why? Oh, this is why. Okay, so this is okay, no, actually we want energy to be greater, so this has to be greater. Then I'm gonna go else if energy stored is greater than 0. Actually, this needs to go up here. So we literally just have a bug in the base code. This is where stuff hasn't been tested, needs to be tested, and yeah. Bugs upon bugs. I wrote this code, probably never tested at any given point, so I need to hit play, remove this debug line because it's not the fault of this code that the reason it was breaking. Oh, come on, debug, remove debug line. Hit play. Pick this gun up, break it, and that's right. Pick block is still not implemented. Okay, this should not fire because it doesn't have ammo. Yep, it's not firing. Okay, so we want to break this, and we want to go get a battery box. I think we can use an RF cell, and the reason I say this is all of my energy code is designed to transmit to all types of energy providers. There isn't some like magical, like it won't work on certain types of machines simply because I've got it set that way. It goes through the energy provider system, and the energy provider system recognizes almost everything as energy providers. And I need to place this above here. Why are you not providing? Might have to use UE cell. Problem is the UE cell doesn't have a infinite system. At least it should have been programmed this way. There's probably some kind of failure here. We got to go find the code. This would be in the core as part of the mod compatibility package. So under mods, then RF, tile RF battery. These are debug batteries, by the way. These aren't actually in the full game. These are just used for entirely testing. So, oh yeah, no, it's programmed to only support RF machines. I must have changed this a while back to test RF support. Is fixable, but I'm not going to do it right now. What we're going to do is break both these again, and I'm going to get UE battery. Problem with the UE batteries is I don't think they're set to infinite. At least I don't think you can. No, you can't set them to infinite. This means this battery will drain. Oh, you can't even set the size. Oh shoot, man, the UE batteries are not even programmed. Okay, crap. We're gonna go with plan B. Plan B is high energy handler. Just implement RF support on the tile. We ship RF with our system, so I don't care. Okay, so we want to get energy buffer size times by RF handler dot 2RF from UE. And this will be math.floor. This is why there's some conversion problems. Is exactly right here. I need to make just a handler at this point. Convert to UE, convert from UE. You know what, I got the game closed. Why don't I just do this? We'll just make a handler here, down at the bottom. So we'll go public, abstract. Why is this, okay, indent with 4 spaces. Why is this whole class janked like that? Everything's shifted over. So public, abstract. You know, actually we don't need to make this abstract. It's already handled on the top here. We just need to do this real quick. So public int 2 UE energy, int energy, and this will be return energy times 2 foreign energy, and then we want to floor this. So I'm going to go math.floor. And the reason I'm flooring everything is to prevent rounding errors. And we just copy this real quick and we go to foreign energy, which is not spelled right when I note this. Rename. think it's how you spell it. Looks close enough. Let me copy and paste this, and Taz, behave, please. So you call 2 foreign energy to get it, and what we're going to do to make this even easier is we're going to make a duplicate of this. So this will be from UE. So this will be from UE, and then we got 2E UE, and yeah, we'll just do this because calling like two foreign is just going to get confusing. And we're going to make this a final method because this is just a wrapper call for that one. And then what we can do in our sentry gun is we can call RF energy handler dot we do that. And we could have wrappered this. I'm actually going to code this all up, and I'm going to go throw it in my machine class up at the top in a second because this needs to be wrappered. Especially this one. This one is... Okay, we actually need this. Shoot. I need to find my version. No, not wireless connector. It's like iTile connector. There we go. And we want to, there's 2 methods in here we need to do. So there's can connect. So there's, we want to call this. The tile that is connect, so we would have to get our tile. So this would be tile entity. Actually, we want to grab this down here. Tile entity connector equals 2 pause dot add from. I think I need to do from.ordinal. Yeah, so it needs to be from.ordinal. Or not from.ordinal, get opposite. So that gets us our position, then we go get tile entity, then world, and that gets us our connection. This will add full support is what we're trying to do. So we want to go if this dot can connect connector, then there's a list of connection types. So connector type, we want to check RF power, and then we want to check power. So RF power first. So we want to go RF power. And then what is it? It's a from direction, so we just need to pass it from. Return true. And then there's the second one we got to do, which is the power. The reason why there's 2 of these is the power is considered the universal version, and then there's a dependent version. So there's a version here for Tesla, RF, IC, and then there's just power. The idea behind this is if we want to make an immersion style mod where you want to have limits between each, you of course want to make sure you're only doing one or the other. So that fixes our connection. Taz, come on. No, none of that. Okay, so this one we need to go energy buffer equals get energy buffer from side. We need to go if buffer doesn't equal null. We then want to return the exact energy value. So we want to return buffer.get energy stored, pretty much. Then extracting and receiving energy are going to be the weird parts, because this is where we have to handle rounding problems. So if there's any rounding issues, they have to be handled to prevent any difficulties. So when we're extracting energy, we want to round up. When we're receiving energy, we want to round down. This means that if there's any rounding problems, there's an energy loss rather than gain. Last thing you want to do is give somebody an opportunity to make an infinite loop. Okay, so we want to do this real quick, and we just want to copy these both up here. And then we want to get the energy. So we want to get energy extract equals buffer dot remove energy. Then we want to go RF energy handler instance dot to UE power, and this will be max extract. Then we want to do opposite of simulate, because we do ours is do action, theirs is do simulate. We then want to take the extraction and convert it back. And this should automatically floor it. The remove energy should, or the 2 energy should automatically floor. And we shouldn't have to worry about rounding issues with here, because if I remember correctly, the conversion is actually a pretty decent number. I think actually we might be 1-to-1. All right. Now this is going to be a similar thing up here, so we want to do this real quick. So we want to go received, and we want to take this and we want to convert it to the UE power. So we're going to go to UE energy from the foreign. Taz, come on. You've been fed today. You don't need to be begging for more pepperonis and crust and stuff. You're getting so pudgy I can almost roll you like a basketball. No. Okay. Okay, this should be floored as well. So this should be both floored. I think we're good. I don't think we have to worry about it too much. I'll test it some more as later to ensure that this does function properly. All we need is it to work. And like I said, I'm going to go copy all of this, and we're going to go drag it to the super, which is the machine class. So machine class already has power code in here somewhere. And we're just going to do this. And we remove all the add overrides over here, so we don't even have to worry about the API for RF being installed. It's the code's here. It works. And any super thing gets automatic access to it. And where were we? Tile Sentry? Cool. Yeah, all we had to do is apply energy or whatever. There's something here. Yeah, energy handler. And we get our stuff automatically. And then I'm, of course, going to create some injection code here later where we can apply RF automatically to tiles. Now that I have the code generator, that is something I'm actually capable of doing now. Go to throw this dog a piece of pepperoni, and she like looks at the pepperoni like it's a miracle. All wide-eyed, her head slightly tipped back, going like, "What is this? It's magic." Some of the funny things about having a pet. They beg for food and you give it to them and they're like, "Wait, you actually gave me food?" I need to make sure I go to the store tomorrow actually and get her some more food. She's down to like 1 packet of liquid dog food. Still won't eat the dry food. There's like a plate of dry food out there. So we're almost done with this. Almost got all the energy code implemented. We're at 45 minutes now, video time. Not too bad. Eventually every turret will end up using energy. The only ones that won't use energy are ones that are probably going to be the client's energy system, which will have its own custom energy handler. Actually, you know the way I can probably do my client's energy system is I could just make his generator output like a constant RF, or output an infinite RF ratio, and then it just powers everything around it to max power. Yeah, that's actually what I'm going to do. That would be so easy. Okay, so I don't need the UE cell anymore because the UE cell doesn't work. That is not an indication that my power system doesn't work, by the way, for those who are about to say that. That literally means I haven't worked on the UE power cells. That's literally all that means. There we go. Come on, work. Maybe I need to power this thing up. It's got energy in it. Set to connect. I know the battery should work because we use it to test the launchers and stuff. Because the IC Beam Classic launchers they use RF. Why aren't you doing your thing? Okay, so we need to test the RF code here. Why my dog continues to whine at me. Come on, Taz. Enough of this. Okay, so... You know, I should just use the energy provider system probably to just handle the whole Sentry Gun thing. There is a whole class system that's designed to handle universal energy. Okay, I'm like nowhere close to where I was wanting to dig through the files system. Okay, so tile sentry, where are we at? Okay, we're going back to the machine super class. Okay, so we get the energy stored. We want to check this method. Okay, so we're getting from down. We got a buffer. Max receive is a lot of energy. Yet we receive 0. Oh. You know why? Because we're hit call and remove. So we want to add energy to storage. Ah, it's working. Doing pathetic damage now, though. Wow, that is really bad damage. I'm gonna up that. That is really low damage. Either way, this is the end of the video though, so we got energy systems provided in here. So these turrets are now can consume energy per tick, consume energy when fired. Energy is customizable per munition type. So eventually there'll be a GUI here to change what type of laser it's using. Actually, there'll probably be an item that'll control what laser it's using. That'll be part of the upgrade system. We'll change its dedicated override round. There'll be a few other things that'll be implemented here. Detachable guns is something we wanted to do, so we want to be able to change out the barrels on these. That is actually what we'll probably do for the lasers, is you'll be able to just change the barrel, and the barrel itself is the laser diode. And that's it. So I don't know what we're going to do next video, but I'll see you guys later.